I know some of you might be thinking, Australian. What would an Australian know about corrosion protection? But let me tell you, we take corrosion protection very seriously in Australia. We're really keen on corrosion protection, right from a very young age. In fact, one of my friends, I have a photo of him here, he's very keen into corrosion protection too, and he usually carries a piece of yellow sandpaper with him in his pocket wherever he goes, just in case he needs to do some additional mechanical surface preparation. I have a photo of him here.
I was like thinking it.
I thought he was in jail.
But I think this goes along. The Australian cricket team is a representation of what the Sspc has been saying for years. That if you don't do surface preparation, then your performance will go downhill. So since this incident, our performance has gone downhill. This is for the, I knew that we would have a lot of Indian friends currently doing battle with Australia in the cricket at the moment. Congratulations, just too good for us at the moment. Okay, onto the presentation. So ACT has been operating here in the UAE and the Middle East for a very long time, and one of the major players when it comes to contracting in corrosion protection, and I'm very proud to have joined there as GM very recently. Some of the things that differentiate us from our competitors and from the rest of the market is that we have our own labour. We do a lot of internal training. They work for us, and we're continually building our skill set when it comes to our labour force. Management is committed to quality and training and delivering on high-end projects for the oil and gas and offshore markets. We have all of our own plant and equipment. It's been built up over many years in doing major projects in the oil and gas and offshore markets. We're operating in Abu Dhabi. We have an office here. We have a facility in Dubai. We have a yard run by my colleague Sanjay, who's here this evening, running the yard up in Hamria, where we can do work inside our own yard for our customers. And we have also established an operation in Oman. So we're quite proud of the work that we're doing. I won't. The services that we provide, we do abrasive blasting, specialised applications. Obviously, our bread and butter is liquid coatings for corrosion protection, but we do water jetting, fire protection, very specialised and a lot of equipment for epoxy, PFP for the oil and gas and offshore markets. We have TSA, which I'll speak a little bit about in a moment. High temp coatings, and we also have a sister company, TAS, that we share offices and resources with, so we're able to provide scaffolding and rope access crews. And our QA team is certified with Sspc and NACE, and I think we have some Frosio still qualified inspectors. Anyone hear that? That's better? Yeah. Thank you. Okay, just a few photos of some of the projects that we have undertaken. As I say, our main focus on the offshore market and oil and gas facilities, particularly in the jack-up, the new build jack-up market. We're very proud of our client list. This has been developed over many years, and we have a strong reputation with, this is not all of them, but some. If there's anyone from our customer base that's not there, I apologise. But that's a representation of some of the major brands that ACT is working for. Just to give you an idea of our organisation, we're currently running a headcount of about 650 workers. And this chart is not, you're not supposed to be able to read all the names on it, but just to give you an idea of the structure and depth of our organisation with maintenance, QA, estimating, and all of the regional offices that we hold. We have a very strong capability in the market. Spoken about what we do, I won't go over that too much. Concrete repairs and coating is also a service that we can provide. And the PFPs. TSA. Internals, we do for, we have equipment and procedures for doing internal pipe coating as well, blasting and coating. Scaffolding and rope access, which ties into our protective coatings services. Okay, this evening I was asked to just give a brief outline of TSA, thermal spray, and I guess how we would go about it from an application point of view. Now, I realise that there's a mix of experience across the room. For some of you, this is going to be very basic, and hopefully it might be a bit of a refresher. For others that aren't specifically involved in the thermal spray, hopefully it's of some interest. And I've tried to put an angle on it as to how ACT approaches these projects. So hopefully this is interesting for you. So what is thermal spray? I've focused on thermal spray aluminium here, but there are a number of different types of wire that we can use for thermal spray. Aluminium, zinc, and then a mixture of both is the three main types of TSA, of thermal spray that you'll see in the market. So you can see that we have a wire coming in from both sides. It's electrified, creating an arc, and then an air jet coming along here, similar to a liquid spray. But for those that haven't seen it, I'll show a video in a moment. But it's very different to liquid coatings in the way that it works. So I have a video here, which I hope is going to work. Okay, sorry. So I'll just pause this for a minute just to give some context to the video. So this is not what unfortunately I didn't have any videos on our file of the work that we've done, but the application process of TSA I think is really well captured from a video. I had to give a video tonight to give you an idea of what it looks like and how it works and how it is applied. The surface that's been coated. This will be freshly blasted steel, and then you can see the different colour on the top, the wider colour is where the molten aluminium is literally being sprayed onto the prepared surface. So I hope that gives you an idea of the application process. So a little bit of technical about how we go about selecting TSA, or I keep saying TSA, thermal spray. TSA is thermal spray aluminium, could be thermal spray zinc as well. But zinc we find is generally used in lower corrosion environments, and it provides a product protection element. TSA is usually used in harsher environments such as splash zone and high temp, which is for this room is probably the more appropriate medium that would be used for most projects. It can last for a very long time. We've seen coatings that have been applied 40 years ago that are still in good shape, and I don't think anyone will provide a warranty for those sorts of durations, but I think the standard talks about a 40-year duration. But it's a very long-lasting coating, and it has been around for a long time, so it has stood the test of time. So, and from an application point of view, I think it's quite clear that it's a higher upfront cost compared with galvanizing or liquid coatings. You're paying a higher premium at the front for a very high performing coating, which will have a lower cost of maintenance over the life of the asset. This is just a photo of one of our machines. This is the ACT. We have a suite of 10 of these machines, so we're able to take on reasonably large size projects. Just a little bit about standards, which is a good starting point when you're looking at TSA projects, and obviously for tonight we look at the Sspc standard. Provides a very clear procedure to follow when it comes to application and QA testing of thermal spray projects. So that's where you want to go, and also to ISO 2063 is the relevant standard on the ISO suite of standards. Application, surface preparation in TSA is really paramount. It's the key to achieving the right result. And as such, most specifications will call for an SA3, which is a very high level of cleanliness, and a surface profile of 65 microns as a minimum is what we should be aiming for. You can use either arc spray or flame spray machines. The literature in the previous slides is around arc spray, which is the most common that we would find in our market. The other critical thing about TSA is the time frame between blasting and application. It's always, even in liquid coatings, it's always important, but in TSA it's even more important. You can't have any flash rusting. The surface has to be absolutely clean. So 4 hours is a maximum. And even on high humidity days, you might find that 4 hours is too much. So that is a critical element of the TSA process. Generally applied at 250 microns, and always we need to make sure that we're applying a sealer coat, an epoxy sealer coat over the top of the TSA is a must, because the TSA finish is porous. We need to make sure that is sealed. When doing TSA safety, safety is always paramount on any project, but particularly with TSA, you can see from the video the arc and the spray and the flame, and also from a visual, other people around the site shouldn't be looking, just like welding, people shouldn't be looking at the arc. So safety and making sure that the men are trained and inducted for those procedures is very important. From a staffing and from a staffing point of view, we find that we need to put a few more people, a few more men attached to these projects. It is hard work. You can see the size of the guns and the work and the heat involved in application. So there needs to be enough staff to do some rotation, as well as providing help for any other manual tasks, so that the applicator is only doing application. One of the interesting things about TSA compared with liquid coatings is that the DFT checks can be done straight away, so the applicator can get a good read on how many passes he might need to achieve the specified DFT with a non-ferrous DFT gauge. There are different wires, different wire thicknesses and gauges, I should say. We find that it's generally better to use a thicker wire for when we can get high productivity, where we're looking at a simple substrate, such as flat plates, and for more complex structures, we use a thinner wire where we can get better maneuverability and better control over the DFT, which again comes back to the project planning. Your machines need to be set up to cater for the correct size of wire that you want to use. Proper planning of the job is critical. We need to make sure that we allow enough time for all of the aspects of the job, making sure that we've got enough blasters to get enough done in a shift, and enough applicators to make sure that whatever is blasted is coated. We also find that maintenance is critical on TSA projects. We need to make sure that the machines are very well serviced, checked before doing any blasting. And we also need to ensure that we've got an electrician. They're electrical machines. We need to have an electrician on site when we're doing these projects. And of course, as with any project, making sure that we've got stock of the correct material in the paint locker. QA equipment obviously has to be calibrated and third-party certified, and if we're doing jobs for third parties, or if there's a third-party inspection required as part of the ITP, making sure that those people are notified and they're ready on site. The QA checking for TSA is a little bit different to other types of project, and there's an interesting picture there of the bend test that's done. So the plate is sprayed with the TSA and then put through the machine and bent, and then there is a pass-fail criteria in the Sspc standard to ensure that the adhesion of the material onto the substrate is there accurately. Top coat, there's no problem with applying a top coat for cosmetic reasons if that's what's required, or to provide additional protection against the sea or against in a splash zone, for example. And as with any normal application project, we're doing the same things in terms of monitoring the weather conditions, humidity, dew point, still temperature, to ensure that our delta is in the right shape. Just the same as any other thing. So I hope that's been of some interest. Thank you again to Pradeep and the Sspc team for allowing us to present, and thank you all for coming, and I welcome any questions.
the video was a well-made video which gives an idea of the system. So primarily, this system is capable of giving a very high life, as Jason mentioned. And the other critical aspect of the system is it cannot be put on by everybody. It's a specialized technique, it's a specialized technology, so the people who are doing it should really know what they're doing. So high level of training, experience and qualification is required. So you'll be spending a lot of dollars, and if it's not put on right, it can fail very easily because the metal is sticking on metal directly. So at this point, I'd like to invite questions from the audience. If anybody has a question, please raise your hand, and we'll pass the mic to you so you can ask. So we do have time for about three or four questions. So anybody?
It's a single wire or double wire? Coaching company.
Sorry, I missed the question. You're asking whether it's one wire or two?
Yeah.
Yeah, two. Depending on the style of the machine. So there are some machines that will have a single wire, and there is the image that I showed is of the two wires that are coming in. So it depends on the machine and the setup and the specification for the project.
It works. So it works like this, what Jason explained. We are using high temperature to melt the metal and using air to spray it out, right? So there are two systems. You can melt the metal by creating an arc. You know, like how we do welding? So we use high current and create an arc. And that arc creates high temperature and it melts. So if we are using an arc system, then we have two wires coming in. The other way of doing it is called a flame spray, where we use an oxygen acetylene torch to melt the metal. So if we are using flame spray and an oxygen acetylene torch, then there's only one. Okay, so that these two different systems. If it's high production, they use arc spray. If it's better quality finish, then they use flame spray.
One question. The top layers you're talking about that you can do the epoxy or polyurethane. But when epoxy, it can be understand. But when you're doing polyurethane, you need to have good quality surface and clean surface. Then how did we can do it?
See, primarily like what Jason explained, the PSA is very porous because if you look at his presentation on the first slide, he shows how the metal balls are coming and falling onto the surface. So they form what's called they form what's called splats, and these build up. So there's a lot of porosity. So the idea of a paint, liquid paint on top of it is to seal the porosity. The selection of the paint is based on the surface condition. So if you want to protect against moisture and water ingress, you would use an epoxy, right? But if you want the surface to be very smooth and you need UV protection and you need color and gloss retention, you would use a polyurethane. If you're putting the thermal spray in a high temperature surface, where the temperatures go up to 400 degrees C plus, then we are talking about using a silicon, aluminum or some system which is capable of taking that high temperature. Yes, can we pass the mic?
My name is Kalimutu. I am from Adnan Gas Processing. Actually, my question is about the pre-qualification test, PQT, you mentioned in your slide. Whether PQT will be done for each and every job, or you will be doing it separately and it will be applicable to all the applications?
Well, it really, as with any project, it really depends on the specification. It depends on the client. We find that normally one pre-qualification test will be required at the beginning of every project. So, and that PQT will be valid for the duration of the project, whether it's a month or 6 months worth of application. We find that most clients will require a PQT for every individual project. And that can include for the applicators as well. So there might be for a qualification test to ensure that each individual applicator is certified for the project and is qualified, and then only the work done by those applicators will be accepted through the project.
Thank you.
Okay.
One more question?
Sorry?
Is there time for one more question?
There is time for one more question if we have one.
Thank you, Jason. Question is more generic. How tolerant is the process of the surface preparation in principle? How well do you need to prepare your surface for thermal spraying? And not just the surface preparation, but also in terms of the, like if you've got a pitted surface or an uneven surface, does the spray, the metal spray, follow the contour, and does it cover it sufficiently? I mean, does it got sufficient edge covering capacity?
Yeah, so that's a good question. I think to answer the first part of your question around the surface preparation, I mean, SA3 is a very thorough clean. So you don't have a lot of variability in the cleanliness of the steel. I have to say that the only TSA projects that I've seen, and maybe ACT has done some others, Sanjay might be able to help me, but I have only seen new builds done with TSA. I haven't seen it being used for maintenance where you would see a pitted surface like that. Sanjay, have you got any, or predict you?
Basically, the surface needs to be very, very clean because it's a metal to metal bond. Surface variations it can take. So if it's pitted surfaces, it can still take and bond with the base metal. In fact, you can put thermal spray even on concrete. So it's not necessary, it is not only restricted to carbon steel. But the surface condition is critical. So that means no oil, no grease, no dust, no mill scale, no rust, no water, nothing. It has to be absolutely clean. So that's the important part. In terms of edge retentive characteristics, the thermal spray is pretty good. It has good edge retention.
Thank you.
Thank you very much. Thank you, Jason.